This is Karan Arora, and basically I am graduated. That is, I have completed my BSc from the mathematics as a major subject. I've also completed MSc again from the mathematics as a major subject. I'm right now pursuing B.Ed, and I am in semester 4, and I will be completing that by this May or June, in a month or so. It will be get completed. Right now, I am here to discuss you about two things. Okay, the two topics. The first topic will be covered as a part of the standard 12th, and the second topic will be covered as a part of the standard 11th. So let me share to you a PPT, and we will be performing two different things. Okay, so let me first make it as a presentation. Yes. Okay, thank you. Okay, so this is a topic that I am going to take. I am Karan Arora, BSc, MSc, and my BEd is pursuing. Uh, so the function, that is the first topic, and I'm going to take the standard 11th topic, which is connected to this. So everybody that is viewing this video will not have a problem to connect between the two topics. The two topics which I am taking, the first topic, that will be function, and the whole thing is around the function only. So what's in, what we are going to see. So as I told you that we are going to see about two things, that is the standard 12th topic and standard 11th topic, right? In the standard 12th, we are going to see the basic of it, that is the definition of the function. We are going to see some example of it, and I'll be explaining what do you mean by domain and what do you mean by codomain, and we are also going to see about the types of the function. In the next part, we are going to view about, we are going to have a discussion about, we can say, the arithmetic progression. We will be first be seeing the definition of AP, that is arithmetic progression. AP means arithmetic progression, and we will be solving sums and having a look, a short look of the formula as well. So this, my things are this we have to complete within the span of the 20 minutes. The first 10 minutes I'll dedicate to the standard 12th part, and the second 10 minutes I'll try to complete all the topics given here. Thank you. Okay, so starting with the function part. What is the function exactly? Yes. Okay, so function is a process, or it is a relation. See, we say the function is by a different name. It can be called as a relation. It is also called as a mapping. Yes, students. So function, relation, and mapping, these are the three names given to a same thing, that is a function. Okay, so it can be said as a function. It is somewhere written in the reference book, it is a relation also. In the somewhere in the reference book, it is mapping. The three names, synonyms of a same meaning, that is a function. Okay, so there is a function. It is a process, or it is a relation that associate. What does the relation means? It associates something to a something. Okay, so it associates each element of x, of a set x, and it is, which is called the domain of the function, to a single element of y of another set y, which is a codomain of a function. So let me explain it to you very clearly. We will be having two sets here. When we are establishing a relation, let me call it like a relation. Okay, so when we call it as a relation, see, we will be connecting two things, something with something. Okay, so we will be connecting here the set, right? So we will be having two set, let it name as x, and the another set will be called as a y. Now what do you mean by set? That we have studied in standard 8th or standard 9th. So standard 8, we have studied that set means collection of things. If I have collection of 10 people of standard 12th, right? I have collection of 10 people of standard 12th which are attending my lecture. So I have the collection. That collection is called a set. Anything which I collected, that is called a set. If I have the test paper of mathematics of standard 12, then it is also called a set, right? So in mathematics, we call collection as a set. So I have two collection. The first collection is x, we name it as a x, and the another collection is y. Okay, what I am doing is, I'll take one member from the set x, we call it as a small x, right? We call it as a small x, and I will be relating this x, I will be relating this x with some member in the another set y, and I call it like small y. So here this member is related with this member, Or we can say this member is mapped with this member. So X is mapped. You can straightforward look it on a cursor because it is an online lecture. Okay, so I have to make a less use of the hand expression, otherwise I'll get clear to it. But you can look at it as a cursor and see the what I am explaining to it. Okay, so we will have X. It will be related to Y, right? X will be related to Y. Okay, so when we are relating some set to another set, what we call first, it is something something, but it is not something, it is a set. Right now we get into the particular part because we are dealing with the definition. So when we are relating one, we can say one set with another set, okay, then it is called a function. Okay, and how the function is denoted? It is denoted by small f, we can denote it by small g, we can denote it by small h, we can denote it by small k. Okay, f, g, h, k, these are the different denotations for explaining or for denoting the function. Okay, so let me take f here. Okay, so here when there is an element x, and if I am relating the function, if I am mapping it, I'll get the answer y. Okay, so I have x here. When I applying the relation, what I get the answer as y. So f of x is equal to y. Understood? Similarly, let us take one more example. For an example, I have a here. I'll get into the example part as well, don't worry about that. Okay, I have a here, and here there is b. There is small a here, and here the element where I am taking from the set y is b. So when I apply the function or the relation of a from x in y, we can say it is b. So when there is an element, say a, you can look at here, this is a. When I am apply the function f on a, we get b. So f of a is equal to b, we say it like that. Okay, now when we are establishing a function from where, when we are taking the elements, like I have taken x from here and seeing the image on the other side. Okay, again taking a from this side and seeing the image on the other side. Okay, like from the, we can take the example of the mirror. We have object and we have the image, right? So this becomes the object and this becomes the image, right? X becomes the object, but in the mathematical way we call it as a domain. X here is called the domain and y here is called the codomain, students. Okay, so when we are like in the, when we are in front of the mirror, what we have, there is an object and there is an image. Here it is also the same process. X, so x ka image is y, a ka image is y, b. Okay, so we can relate it like object and image, right, students? So here the object, the set of the object is called domain and set of the image is called codomain. We have one more definition. This one is somewhat easier definition, but we have one more definition that is given in your textbook. What is the definition? Have a look to it. If a and b are two non-empty set, likewise we have taken x and y, we can also take a and b. So let us take two sets. There are two sets, and I'll explain to you this part also. We have two set a and set b. We have two sets, set a and set b are the two non-empty sets, and each element of set a, every element, like let us take a1, a2, a3, a4. Let us take four elements which are in set a. Okay, so set a consists of the four elements. Now remember, each element of set a is related with one and only one element of set b by some rule, relation, or correspondence. These are the different name of a function. Each and every word represents the function. So what does it means? That every element of a, which are the elements of a1 is an element, a2 is the element, a3 is the element, and a4 is the element. Each and every element, okay, is related to the element of b. Like for a1 we will have b1, for a2 we will have b2, for a3 we will have b3, and for a4 we will have b4. So here each and every element is related to the some element in the set b. Then we call it as a function. Then it is called a function. Okay, and the function, as I said, it is represented by f, g, h, and k, students. So I think we are clear on it. Let us one more we'll take example, one more example we'll take, and we'll move further. For an example, let us take now numbers. Okay, let us take the numbers part. Okay, the relation what I am establishing is 2x. 2x means अगर हम लोग x लेंगे तो उसका डबल हो जाएगा. ओके, यानी वी आर गोइंग टू द डबल पार्ट, वी आर रिलेटिंग द नंबर टू द डबल पार्ट. सो फॉर एन एग्जांपल आई विल टेक 1 2 3 एंड 4. ओके, सो 1, अगर 1 हम लोग अप्लाई करेंगे तो 1 का डबल दैट विल बी 2. 2 2 into 2 that will be 4. 3 into 2 that will be 6. Double of 4 we will get 8. Okay, so this is a set A, this is a set B. There are two sets, set A and set B. Okay, we are applying the doubling of an element, we are applying doubling of an element. So if we take 1, okay, the answer for the 1 is 2. If we take 2, the answer for the 2 is 4. If we take 3, the answer for the 3 is 6. If we take 4, the answer for the 4 is 8. Okay, so this means what? It is a function. This is a function. Okay, the function is what? F of x is equal to 2x. Okay, so when we have taken 1, the 1 is related, or 1 has the image called 2. Okay, in the opposite set you have to check the image. You are taking 1, you are picking 1. Where will you check the image? In the another set. If you are taking the 2, where you check the image? On the another set. So 2 ka image is 4. When you are taking 3, so you are getting the image 6. When you are taking 4, you are getting the image 8. Okay, you can solve it like this also. You can solve it like this, nothing in that. So if you are given with f of x is equal to 2x, and x is given like 1 comma 2 comma 3 comma 4. Okay, so when you take x is equal to 1, if you take x is equal to 1, so f of, see here we have the function f of x equal to 2x, we are taking x equal to 1. So in every place of x we'll put 1. So what will happen? X is equal to 1, so that will be 2 into 1. What is 2 into 1? That is 2. When we take x equal to 2, so f of 2, okay, so that will be 2 into 2. 2 into 2, that will be 4. So when we take x equal to 3, in this part put the value x is equal to 3. So f of 3 is equal to 2 into 3, that will be 6. And when we take x is equal to 4, then f of 4 is equal to 2 into 4, that will be 8. So you are getting the same answer, 2, 4, 6 and 8 students. Okay, again what I repeat is, please try to understand where we are taking the elements. When we are taking the elements, that set is called the domain. So we are taking the element from this set A, so here A is called domain, and where we are getting the image, that set is called codomain. Okay, so that is called codomain, we call it as B. So there are two sets. Okay, we have to pick the element from domain, and we have to reach to the another set for checking the image of it, and that set is called codomain, students. Okay, we can represent the function like this also. The f is a to b. What does a to b relate? Let us check it out. What does a to b related? See, f when written a to b, that means A is domain and B is codomain, right? A is domain and B is codomain. Second thing, we have to pick the element from A and we have to check the image in B. That is the two things. Okay, for an example, if we are given with f of x to y, that means x is a domain and y is the codomain. Where we can pick the element from the set of x, we have to pick the element and check the image on y. Okay, so that is the things I think it should be clear to you now. What does the function means? Function means that we are relating two sets. Which are the two sets? They are domain and codomain. We'll take the elements from domain and check the image on the codomain. That things we are going to see here. Now, giving a little touch in it, let us take one example of it. I'll be solving one because of the lack of the time, and you have to check another example, and you have to note down these sums. Okay, and if you have any doubt, you can ask me in personal, or you can check the personal group also. You can have a chat on the group also. Okay, so what is to be done here? See, the things are given to you, like you are given with the set A. Okay, set means a collection. You are given with a collection like a equal to 1 2 3 4. Okay, we have 1 2 3 and 4 as a set A. In B, what we have? We have the elements 3 5 7 9. Okay, and we have the function that is given to us as f of x is equal to 2x plus 1. This is main thing. Okay, this will be given in the question itself. Okay, and we have to check whether it is a function or not. Let me make a diagram of it, because to understand the concept, first of all the diagram should be very much clear. I believe in that. Okay, it is not so that the things are working like this. We have to write the step and you have to mug up the step and you have to put all the step into it. That thing will not work when the sums are given in a logical part, or when you get into the JEE exam. That things are not going to work. So the thing which will help you is the concept. You have to stick up to the concept and solve the sum by making the concept clear. Okay, so the function here what is given? X belongs to A. Matlab you are going to pick the elements from A and you are going to check the image on B. What are the elements of A? 1 2 3 4. So 1 2 3 4 are the elements of A, and in B we have 3 5 7 9. So 3 5 7 and 9, these are the element in B. Okay, see here, x belongs to A, matlab x we are going to take from A. Okay, so we have the function f of x is equal to 2x plus 1, right? So let us take one by one x from A. So what we are going to take? X 1 2 3 and 4. Okay, so let us take x equal to 1. So if I take x equal to 1 and will put 1 in the place of x, so wherever there is x, we'll put 1. So here, first of all, there is x, so we'll put 1. Then it will be 2 into 1 plus 1. What is 2 into 1? That will be 2 plus 1. 2 plus 1, that is 3. So for what we can say? 3. Where is 3? So 3 belongs to set B. So 3 belongs to set B. What I have done, see students here. I have taken x equal to 1 and I have checked the answer is in B. Means the 1 is related with 3 from the codomain. डोमेन से हमने 1 लिया और हमको कोडोमेन में 3 मिला. Okay, proceeding in a similar fashion, we'll take 2. So x is equal to 2. What we can get? We'll first put 2 in place of x. So f of 2 is equal to 2 into 2 plus 1. 2 2s are 4. 4 plus 1, that will be 5. Is 5 belongs to B? Yes, 5 belongs to B. That means what? 2. We have taken 2. See, x equal to 2. Okay, we have taken 2 from A and we have got the image that is 5. So 2 ka image is 5. In a similar fashion, let us take 3. Okay, so x equal to 3. So what we can get? F of 3 is equal to 2 into 3 plus 1. So that will be 6 plus 1. That will be 7. And 7 again belongs to B. You can see here. So 3 is related to B as 7. Okay, the image of 3 is 7. Okay, proceeding like this only. Let us take x equal to 4, the last element. Okay, so what we get? F of 4 is equal to 2 into 4 plus 1. Okay, because it is 2x plus 1. So 2 into 4. X ki jagah pe 4. So 2 into 4 plus 1. 2 into 4 plus 1. That will be 8 plus 1. And 8 plus 1, that will be 9. So we get the image of 4 as 9. So we can see here that each and every element of A is related to every element of B. So yes, in the last part, as a part of the conclusion, we'll write yes, it is a function. Okay, what you have to see, that every element of A is related to another element of B. You can take it like this also. There are two villages. Let us take village A and village B. Yes, it is kind of two villages, village A and village B. And we have to relate every member of this village into another member of the opposite village. Okay, the first village is named as domain and the second village is named as codomain. That thing should be made clear, students. Okay, now, so this kind of image we get when we solve. Okay, it is not always like a straight line. Okay, it is not always like this, that image of 1 is 3, image of 2 is 5, image of 3 is 7, image of 4 is 9. It can be like this also. But the main thing should be clear, that every element of domain should have an image in the codomain part. Every element of domain should have a clear image on the codomain part. For an example, 6, here it is related to -5, 3 here related to -2, 0 is related to 8, -1 is related to 0, and 14 is related to -5 again. But the main thing we should watch here, we should view here, or we should observe here, that every element of this domain is related to the another set, okay, the codomain. Okay, no element should be spared. Each and every element should be mapped. That thing should be made clear, students. Okay, now we are looking for the types of the function. We go for the types of the function. What are the types of the function? There are 3 types of the function. First of all, due to lack of the time, I'll just make the picture, okay, in front of you and explain from there also, or explain from that only. But if we are given much more time, then I'll get you into the definition part as well. But first, make the 3 words clear. That is one, many one, and constant. These are the 3 types of the function. Okay. So whenever you are asked how many types of the function are there, this is not only for 12th standard. It is in your graduation part also, in the engineering part also. This question, or in the BTech part also, this function is the most important thing. And from that also, you have to rectify which type of the function is that. Okay. So please make this name very much clear in your mind, in your brain. Okay. So the types of the function are one function, many one function, and constant function. Okay. So we are not going to the definition part. We'll just have a look into the figure and we'll try to take some notes on the figure. So the first figure is like this. This is what we call as a one function. One function means what? That each element, you can see here, has the unique image. Each element has the unique image. Each element has a unique image. No 2 elements have the same image. That is called one. Each has unique image. That should be kept in the mind. One function means what? Each element should have the unique image today. Now what does many one suggest? It is just opposite of one. This all the diagrams are given in your book only. So don't worry of copying the diagram. Okay. You can see here many one means what? Here many have single image. So many elements from set A are mapped to set B. Set B, many elements of set A are mapped to one image of set B. Okay, so that's why the name is many. You have to take the many from this set, and one you have to take from this set. So many elements are mapped to a single element of the set B. Many elements of set A are mapped to set B, one element of set B. Here what is going to was going to happen? Each element has the unique image. So one element has one image. No 2 elements are going to be have single image. But here what is going to happen? That 2 elements are having same image. Here each element has only one image, but here 2 elements have same image, student. Okay, so this is called many one function. This is many one function where 2 or more than 2, it can be more than 2 also, where 2 and more than 2 or more than 2 elements can have one image, where 2 or more than 2 elements can have one image. That is called the many one function, student. Okay, and what do you mean by constant function? Constant means what? It doesn't changes. So all the elements have single image. All the elements are linked to only one element, have only one image, are mapped to only one element. So when we say the constant, these are the 3 types of the function. Understood, student? The first type, one. What is one? What is one? When each element is linked with only one element, it is called one function. What is many one function? When many element of one set is linked with the only one element of the another set, that is called many one function. And the third one is constant function. Constant function means what? Where many element of set A is linked with only one element of set B, then it is called constant function. Okay, again I repeat, let it be clear, this should be kept in the mind because it is the most important part of your this boards as well as of your future, wherever your maths is going to come. The first thing is one function. What is one function? Each element has unique image on the codomain. Second one is many one function. Two or more than two elements having the same image, having only one image, that is called many one. Constant function, all the elements having the same image is constant function. Okay, so this is, I think, standard 11th part, arithmetic progression. Very basic topic. This topic has been covered in standard 10th also. It is the topic of standard 10th AP that you have studied. That was the 5th chapter of your NCERT, arithmetic progression. So when I say the progression, what does this word suggest? So progression means a type of sequence. Progression means a sequence. And arithmetic, that is something that has logic, we can say. We can say it is a logical sequence. Okay, let me come up to this word also, sequence. Sequence means the list of the numbers. Okay, so basically what does the progression suggest? Progression suggests the list of the numbers. The numbers, they are in the list. Okay, they are in the order, but that order should be maintained logically. Okay, let us have a look to the definition, a quick look to the definition. Arithmetic progression is a sequence of the numbers in order which the difference of any two consecutive number is a constant value. Means the difference of the two numbers, any two numbers, or we can say any two consecutive numbers, should have the same value. Then this sequence is called arithmetic progression. Let us take some different examples. Let us take like 1, 2, 3, 4 and so on. This is an endless sequence. It is an arithmetic progression. But how can we check? Is it so? So the difference should be constant. See, difference should be a constant value. So if I minus 2 and 1, if I minus the consecutive terms 2 and 1, the answer to this part is 1. If I minus 3 and 2, the answer to this part is 1. If I minus 4 and 3, the answer to this part is 1. You can check, all the answers are 1. Okay, let us take some another list of the numbers. For an example, 2, 7, 12, 17 and so on. Okay, so here the subtraction of the two number, that is 5. Here the subtraction of two numbers, consecutive numbers, 12 minus 7, again that will be 5. 17 minus 12, again that will be 5. So you can check here the difference is constant. Whenever this type of sequence or whenever this type of listing is given, where the difference of the two consecutive terms is constant, that is called the arithmetic progression, student. And that you might have studied in standard 10th also. Okay. So these are the basic things that we have to keep in the mind. First of all, I let you know what is the general form of AP. Okay. So you have to note that the general form of AP can be written as A plus D, A plus 2D, A plus 3D, and so and so. Okay. So what is A here? Here A is called the first term, students. A is called the first term. And D is called the common difference, students. D is called the common difference. Okay. So what you are going to take, you can note it here like A is the first term and we will have the difference added to it. So we get the successive term. For an example, if we add D into A, so I get A plus D. So this is my second term. If I add again D to the second term, I get A plus 2D. So I get the third term. If I again add D to the third term, so I get A plus 3D. This is my fourth term and so and so. So this is a kind of a general form. You can have a note on it. It is a general form, students. General form of AP. What is the general form of AP? The first term is A and we are going to add D to each and every term. So on the first term, we have first term as A, then A plus D, then A plus 3D, then A plus 4D, and we get the general form of an AP. Okay, so definition here it is given. An arithmetic progression is a sequence which is in the form of a plus d, a plus 2d, up to a plus nd, and so and so. Where the initial term, it is also called the first term, students. Where the initial term of the first term is a, and the common difference is d. Okay, are the real numbers. So a and d should be the real numbers. Means a and d should both belong to the real number set. Okay, students, I'll just make the formula part clear, then we'll again have a look onto this part on the last slide. The formula for that is Tn. It is sometimes written as An also. Okay, we have the AP. First of all, let me clear the AP part. The general form of an AP is A, then we have A plus D, then we have A plus 2D, then we have A plus 3D, and it is moving like this. Okay, so Tn is equal to An, and we will give here A plus n minus 1D. This is the formula in general. A plus n minus 1D. This is the in general formula. Okay, so let us take one example looking to it. Let us take one example. For it, let us take f of x. F of x is equal to x plus 1, where x belongs to a natural number. Where x belongs to a natural number, and we have to form an AP. This is a function given to you, and we have to form an AP. Now you know what is the function. Okay, so what is the natural number? First, it is the number starting from 1. It is the collection starting from 1. So 1, 2, 3 up to so on is the natural number. So let us take x equal to 1 first. So what I get, f of 1 is equal to 1 plus 1. And what is 1 plus 1? 2. Okay, this 2 is my first term. If I take the second term as x equal to 2, this will be f of 2. So that will be 2 plus 1. 2 plus 1 will be 3. If I go to x equal to 3, I get f of 3 is equal to 3 plus 1. 3 plus 1 is 4. If I go to x equal to 4, I'll put x equal to 4. So f of 4 is equal to 4 plus 1. That will be 5. Okay. So my AP will be, so the AP, arithmetic progression of the sequence of the numbers, will be 2, 3, 4, 5, and so on. Okay. So this is how we can form an AP. Okay, so I think my 20 minutes are up, and I stop here. In the next lecture, we are going to see some sums as well. Thank you for the same.